All right, today we're looking at 5.5, solving polynomial equations. So if you can kind of think back to that first half of the chapter before break, we kind of explored polynomial functions. We added, subtracted, multiplied, and divided. Then we looked at what polynomials actually are. And then we started analyzing parts of the graph, okay? The second half of the chapter is going to be all about solving polynomial equations and how to find algebraically those intercepts. I know we used our calculator on some problems to find the zeros before break, and now we're actually going to find out how to algebraically solve them. In the first section, 5.5, should be pretty familiar to you because we're going to talk a lot about factoring, right? And here are some new patterns that I would get down for your notes, okay? These are important patterns, and because they kind of deal with polynomials, okay? So we have sums of cubes and difference of cubes. The other one to kind of keep in the back of your mind, if you don't remember, is from chapter 4, and that's when we have a difference of squares. So if you had like x squared minus 4, that would always factor into x plus 2 and x minus 2, okay? So that's kind of something to keep in the back of our mind. That's from chapter 4. That a factoring pattern is still valid. And then we have these two new ones, which are difference of cubes. Again, these patterns, we don't necessarily know, or sorry, not, we need to know. I'm going to give them to you on anything, okay? So let's just dive right into things. I'll try to leave those patterns up there so you can kind of see. But let's start. Remember, just like in chapter 4, when we want to factor, we want to look for the greatest common factor first. So I want to look at these two terms and see if there's anything common I can pull out first, which in this case, it looks like I can pull out a 5y first. And then I'm left with a y cubed minus 64z cubed. So if I take a 5y out of both, that's what I'm left with. And now, if you notice, it looks like these are perfect cubes. The cube root of y cubed is y. The cube root of 64z cubed is 4z. All right. So now what I can do is, since I have a difference, I'm going to use my difference of cubes pattern. And I'll try to line this up so you can kind of see. But our 5y stays the same. If we look at our pattern, it's always a minus b. All right, so hopefully it's kind of clear where those came from. That's the cube root of y cubed and the cube root of 4z. And then we go through this. We have a squared plus ab plus b squared. So we want to take y and square it. We want to multiply y and 4z together. We're going to add that. So we have 4yz. And then we want to square 4z, which is 16z squared. All right. Please note the signs in these patterns will always stay the same. Your a, in this case, is y. Your b is 4z, not negative 4z. We have that subtraction sign, so I'm going to use it. If you wanted to change it to adding the opposite, then you could use the sum pattern. But I'm using the difference pattern, so my signs stay the same. And that is how we factor the expression. All right, we're going to do the same thing on b. Looking for the greatest common factor. Looks like the only number I can pull out here is a 2. And I wind up with 8x cubed plus 125. Hopefully some red flags are kind of going off right now, and you see that those are both perfect cubes. The cube root of 8x cubed is 2x. The cube root of 125 is 5. 5 cubed is 125. So I'm going to use that to finish off my problem. I'm using the pattern, and this time I'm going to use my sum pattern. which is right here. So I want to do a plus b, so 2x plus 5. And then I'm going to square the 2x, so I get 4x squared minus a times b, 2x times 5 is 10x plus b squared. And that is how we factor that expression. All right. So below, I'm just going to give you a second to kind of look this over. This is just kind of a refresher of factoring techniques. We should always do that first step, which is find the greatest common factor if there's any. Pull that out first. All right. And then a lot of these strategies, difference of two squares, this is chapter 4. This is going to be chapter 5, the sum and difference of two cubes. And then kind of looking at our general trinomials, this is what we talked about, or all of these patterns kind of thing. You don't need to memorize these patterns. Just remember when we have a trinomial, we're looking for the factors of A and C that add up to B, and then we use grouping to solve from there. All right. Again, those patterns aren't super important. I don't expect you to memorize those by any means. But let's go into some more complicated examples. All right. So notice we have 6 terms here. There's 2 ways we can approach these problems. We can either do 2 groups of 3 or 3 groups of 2. Okay, you're going to want to try both. The nice thing about these problems, though, you guys, is we're not here to trick you. So it's going to be 2 groups of 3, 3 groups of 2. You don't need to rearrange the terms. Okay, we're not going to, mess everything up and try to make you spend 5 hours on a problem. It either groups nicely or it's not. So it looks like I see x, x, x. So I'm going to group 2 groups of 3. And then we want to take out anything that's common. And it looks like out of this first group, I can take a 6x. I'm left with 5a minus 4b plus c. All right. What can I take out of my second group? What is common there? It looks like my y squared is common. And then I wind up with 5a. Whoops, it's not plus 4b. We took out a negative y squared, so it's minus 4b plus c. If we group correctly, or if we can group, those should always be the same. So we wind up with 6x minus y squared, and then we have 5a minus 4b plus c is my answer. Again, factoring, we're looking for those patterns. What can we pull out? If they're the same, then we can factor by grouping. All right. Looking at this next one, things look a little dicey, right? I mean, I see some A's, I see some B's. I might be able to rearrange things, but when I look at those numbers, 13's prime, right? And it doesn't look like I could do this. It doesn't look like I could do this. So as we go through this, if we cannot factor, what we do is we say this is a prime polynomial, meaning we cannot factor it. All right. We'll go into the last few problems here. A lot of our factoring problems, if you think back to chapter 4, actually do combine several methods. So these are a few problems that are a little more complex when it comes to factoring. So the first thing we're going to look at is this. All right. I noticed I have 2 terms and it's a difference. So I'm thinking difference of squares from chapter 4. All right. So I'm going to go x cubed plus y cubed and x cubed minus y cubed. Remember that pattern before, a plus b and a minus b. And then at this stage, hopefully you're like, whoa, we just talked about these cube patterns. I can factor those yet again. If you remember the pattern from the front, it's a plus b. We have a squared minus ab plus b squared. That's the sum of cubes pattern. All right. Our difference of cubes pattern is a minus b, a squared plus ab plus b squared. And that is how you factor this problem. One quick pointer, when we use that difference of cubes or sum of cubes pattern, that resulting trinomial will not be factorable. All right, typically. I'm almost positive we never have you factor beyond that. So that's just something to keep in mind with those problems. Most of the time, you cannot factor those trinomials any further. All right, approaching example B here. I see 6 terms. I'm kind of honing in on the x cubes and the y cubes. So I'm going to do 2 groups of 3. What can I take out of my first group? Well, an x cubed. And then I'm left with x squared plus 4x plus 4. Looking at my second group, it looks like I can take out a y cubed, and I wind up with x squared plus 4x plus 4. Hey, man, it's like we planned it. It's unbelievable. We wind up with x cubed plus y cubed, and then we have x squared plus 4x plus 4. And then we actually can factor again. You want to keep going until we can't factor anymore. So sum of cubes becomes x plus y, and then we have x squared minus xy plus y squared. And then if you notice here, we have a perfect square trinomial. If I were to factor this, I would get x plus 2 and x plus 2, or x plus 2 squared. And now I am done factoring this polynomial. Hopefully you guys can kind of see what this is getting at, is once we get to our factored expression, we can use either maybe the quadratic formula to solve, or I can solve each of those by setting it equal to 0. And that's kind of what we're working towards today, is all of our problems can factor, which means you should have some fairly nice answers, okay? On this last example, we're actually going to solve, we're not just going to factor, but we're going to use factoring to solve the situation. It looks like we took a chunk out of a large cube. So if I think about the volume of the shaded region, I'm going to have to subtract the big from the small, or the small from the big. Sorry, I said it wrong. All right. So the question is, what is the volume of the large shape? Well, it is 2x cubed. All right. The volume of the small shape is x cubed. So if I subtract those two, I'd be left with the shaded region. In this case, it says the small cube is half the length of the large cube in the figure. So the shaded figure right now is 7,000 cubic centimeters. What should the dimensions of the cubes be? All right, so we're going to solve this. We wind up with 8x cubed minus x cubed. So we have 7x cubed, 7,000. Okay. I know right now most of you are thinking, well, you know, he could just divide by 7 and cube root both sides. But since today is all about factoring, I'm going to take the longer route. You know, it's about the journey, not just the answer. So I'm going to move the 7,000 over, set it equal to 0, just like we did back in chapter 4. And then hopefully some of you are seeing this is a cubes pattern. So we took out the 7, we're left with x cubed minus 1,000. So then we're going to use our difference of cubes pattern, which is x minus 10, x squared plus 10x plus, I'm running out of space, that should be 100. All right. So then we'll continue to solve. We know that one of our answers is 10, and we know these answers. I guess we don't know it right away, but those answers, if we were to figure out the discriminant, remember b squared minus 4ac, we would find out it's a negative discriminant, which leads us to two complex answers, which means the only answer here that works is 10, which means the dimensions of the small cube would have to be 10 by 10 by 10, and the dimensions of the big cube would have to be 20 by 20 by 20. And that's the end of the lesson. All right. Homework's on the bottom of the page. Remember, EOE and mod 4 just mean make sure the problems should be are divisible by 4. It's kind of our way to shorten things up a little bit more from, just doing evens. If you do have any questions, chime into the discussion board or ask during the live feed. Otherwise, I wish you the best of luck on section 5.5. It's a good lesson, and for all of you who love factoring, 5.5 is for you. Enjoy your day.